We're going to do a few problems now that involve the chain rule mixed together with product and quotient rules. So there's nothing actually new here. It's all stuff that you could have done already. I'm just going to do some practice problems because, sometimes when we mix multiple rules together, it just gets a little messy. So when I look at this first problem, this looks like a chain rule problem to me because I have a function inside of the fourth power. So my outside function here looks to be x to the fourth, and my inside function is all that stuff, the x cosine of x plus 1. The derivative of x to the fourth is 4x cubed. And then the derivative of this piece, the derivative of 1 will be 0. But I notice that the x cosine of x, that's a product rule because I have x times cosine. So I'm going to have to do the product rule on that piece. So the derivative of x is 1. We leave the cosine x alone. Then I leave the x alone. The derivative of cosine is negative sine. So I'm going to go ahead and make this negative sine. And then, like I said, the derivative of 1 is 0, so plus 0. Okay, now we put this all back together. I'm going to plug my original inside function into the derivative of the outside function to get 4 times x cosine x plus 1 cubed, and then I'm going to multiply that by the derivative of the inside. Okay, so nothing different than a normal chain rule problem there, just mixed together with the product rule. Okay, so if I look at this next problem, this looks like a product rule to get started because I have two pieces multiplied by each other. So I need to start with the product rule here. In the other one, the product rule lived inside of the chain rule. So the derivative of the x cubed is 3x squared. I leave the e to the 4x alone. Then I leave the x cubed alone, and I have to take the derivative of e to the 4x. The problem with the derivative of e to the 4x is that there is a function inside of a function there. So I'm going to need the chain rule on this piece. And I'm going to write my answer over here. So let's do the chain rule just on the e to the 4x, or e to the x to the fourth. Sorry, hard to read that. So my outside function there is e to the x. My inside function is x to the fourth. Derivative of e to the x is e to the x. Derivative of x to the fourth is 4x cubed. So I'm going to write my answer up here. So I'm going to plug x to the fourth into e to the x. So I'm going to get e to the x to the fourth. And then I'm going to multiply that by the derivative of the inside. So multiply by 4x cubed. Okay. So notice here that we started out with the product rule because the first thing, kind of the outermost thing that's happening in this problem is two things getting multiplied by each other. Okay. If I look at this next one, it looks like I have a function inside of a cosine, so it looks like I'm gonna have to start with the chain rule. So my outside function is cosine of x. Its derivative will be negative sine. My inside function is that messy quotient. And this is where I'm going to have to do the quotient rule on the derivative of the inside. Whoopsie. So I have low d high, so x squared plus 1 d high will give me 9x squared, d minus high, d low will give me 2x all over low squared. Okay, this is going to be fun. We could probably simplify that quotient rule piece a little bit. Yeah, let's go ahead and do it just to make our lives a little bit easier. So I'm going to get, if I multiply out this piece, I'm going to get 9x to the fourth plus 9. I'm going to get 6x to the fourth, and that'll be minus 6x to the fourth. And this next piece is going to be positive because I have a minus and a minus. So I'm going to have plus 2x all over x squared plus 1 squared. These two terms will combine to give me 3x to the fourth plus 2x plus 9 all over x squared plus 1 squared. Okay, you did not have to simplify that. I'm only simplifying it because I'm going to have to rewrite it, and it looks maybe a little bit nicer. So if I put my final answer all together, I'm going to plug my original inside function into the derivative of my outside. So I get negative sine of 3x cubed minus 1 over x squared plus 1. I'm going to multiply that all by this piece, which is not fun to rewrite, but I'll rewrite it. And again, if you had left it in the unsimplified version, that would be fine too. That's just more to rewrite. So I get 3x to the fourth plus 2x plus 9 all over x squared plus 1 squared. Okay, cool. That's all we have to do there. And then let's do this one. This one's a little bit more abstract problem. So we are given information about our function g of x, and we want to find y prime of pi. This means I'm going to find y prime and then plug pi in. So let's start out by finding y prime. So this looks like a product rule to get started because I have two functions multiplied by each other. The derivative of x squared is 2x. I'll leave the g of cosine of x piece alone. Then x squared stays x squared. Now I need to take the derivative of g of cosine of x. That's going to be a chain rule. And that's going to belong here. So my outside function will just be g of x. My inside function will be cosine of x. The derivative of g is just g prime. The derivative of cosine is negative sine. So when I put this all together, I plug cosine into g prime. So I get g prime of cosine of x. All of that times negative sine. Okay, so that's y prime. Now I'm going to plug pi into this to get y prime of pi. So I'm going to get 2 pi. Cosine of pi is negative 1, so I'm going to get g of negative 1 plus pi squared, g of negative 1. Sine of pi is 0. So that means that this whole term is getting multiplied by 0, so it's all going to be equal to 0. Kind of makes my life a little bit easier. And so then we can use the information that they gave us above to see that g of negative 1 is 4. They've given us a lot of information that we didn't actually need to use, but that's okay. So I can have 2 pi times 4, which is just 8 pi, and just leave it like that. You don't have to shape that into a calculator if you don't want to.